Hello everyone. Today let's solve the problem number 143, reorder list. So you can just go through the question and you can just go through the example to understand the question better. So I'll just summarize the question for you so that it will be easier to understand. So what the question states here, we are given the head of the singly linked list. You can clearly see here, we are given the head of the singly linked list. The goal is to order the list so that nodes alternate between the first and last nodes. This is very important. We'll see this one. The goal is to, just listen to this. The goal is to reorder the list so that nodes alternate between the first and last nodes. The transformation is described as they have given here in this way. L0, ln, L1, ln minus 1, L2, ln minus 2. First element and last element, second element and last but one element. The process, we can just further move in this way itself, right? So here you can clearly see 1, it has to be 1, 4, 2, 3, like that. The output we need to get in the same way. 1, 4, 2 and 3 here. Here also the same way. 1, 2, 3, 4, 5 they have given. First element, last element. 1, 5, second element, last but first element. 2, 4 and finally this one. We don't have another number for this. So this will be single number. 1, 5, 2, 4, 3 will be the output. So I hope the question is clear. We need to get the output in that way. We are not allowed to modify the node values. They have strictly mentioned we are not allowed to modify the node values. Only the pointers can be adjusted. We can only adjust the pointer. That's what they have given in the question. So what we'll do, initially let's discuss the approach, then let's discuss all the edge cases as well, and then write the code and discuss the complexity of the code that we have written. As usual, we'll be discussing the approach initially. Let's go with the approach step by step. So what we'll do, first step is here we will be traversing the list to collect all the nodes in the array. We have to traverse through the list, right, to collect every node in the array, right? We will be traverse the list. Why we are traversing the list here? Because to collect all the nodes in the array and array, right? This will be the first step. After traversing through the list to collect all the nodes in the array, we'll be making use of the two-pointer technique. We'll be making use of the two-pointer technique or two pointers here to reorder nodes from start and end respectively. Why here? To reorder nodes from start and end. The first pointer will point to the first index and the last pointer will point to the last index, and we will make use of the two pointers effectively to reorder the nodes. That's what we'll be doing in the second step. And let's move on with the third step here. So third step will be adjust the next pointer of the nodes to achieve the required order. So we will be, this is very important step, we will be adjusting the next pointer to, why we are adjusting the next pointers of nodes here? To achieve required order. So the order I have already shown, they have clearly mentioned in the question, right? So I have already shown the example to achieve, one second here, yeah, to achieve required order. We'll be adjusting the next pointer of the nodes to achieve the required order. This is the approach that we'll be going with. First, what we'll be doing, we'll be traversing the list to collect all the nodes in the array, first point, and we'll be effectively making use of the two pointers to reorder nodes from the start and end effectively. That's what the second thing says. And the third step is we have to adjust the next pointers. This we have to keep in mind. We have to adjust the next pointers of the nodes to achieve the required order, right? So this is the approach that we'll be going with. So let's discuss the edge cases step by step and then write the code and discuss the complexity of the code that we have written, right? Now let's discuss the edge cases. So first edge case, let's discuss about the single node list. When I say single node list, let Let me consider the input 1. Here the output will be 1 as well. Why? We have only one node here. No reordering is required or needed at all. So the output will be obviously 1. So this is for the condition single node list, right? This is first edge case. Second edge case is 2 nodes. Suppose we are having the 2 nodes, right? We'll be having 1. Let's consider 1 and 2. The output will be here 1 and 2 as well. Why the output will be 1 and 2 here? We have the alternating structure that is already satisfied. Means the list here remains unchanged. First element and the last element, 1 and 2, same thing, right? So the output will be 1 and 2 itself. So here this is for the condition 2 nodes. This is fine. Let's move on with the third edge case, nothing but odd length. While I say odd length, let's take the input in the which have the odd length. I will just consider here 1 2 3 4 5 as input here, and output will be here first and the last element, first 1 comma 5 and second and the last but one element 2 comma 4, finally 3, right? So the output will be 1 5 2 4 3 here. The middle node, here you can see the middle node, this one 3 remains in the place of the reordering. You can clearly see here the middle node remains in the place of the reordering. So the last one we'll be considering here is, we have already considered the odd length. Let's consider the even length now. So when I say even length, let me consider here 1 2 3 4, right? 4 is of even length obviously. So let's go here 1 and 4, second and last but one element, nothing but 2 and 3. 1 4 2 3 will be the output here. So we are just alternating between the first and last nodes that continues without leftover nodes, right? So this is for the even length. So I hope these are the edge cases that we need to consider. First one is single node list, second one is for the 2 nodes, third one is for the odd length, fourth one is for the even length. I hope all the edge cases are clear. Next, let's start writing the. So as we had discussed in the approach, let's collect all the nodes in the array. So let me give here, let me initialize this one to the empty array initially. So this is just the array to store the nodes. Next step is, we have to make use of the pointer to traverse the linked list. Let me give here current equals head. So after this, we have to traverse until the end of the list, right? So I'll just consider quick while condition here. So let me pass the current, right, as the parameter here. Let's push each node into the array. We have to push each node in the array. We have already discussed this one in the approach. So let's consider here nodes dot push of current element. This is fine. Finally, we have to move to the next node. For moving the next node, let's just give here current dot next. Let's initialize current to current dot next as we are moving to the next node. I hope this step is clear. Next step is, we have to reorder using the 2 pointers. We need all the elements in certain order that they have given in the question, right? So we have to reorder. We are just reordering the list using the 2 pointers. How can we reorder? Let's see that one itself. I'll just initialize L to 0, R to last element, nothing but nodes dot length minus 1. This is fine. Next step is, while the 2 pointers haven't crossed yet. So here let me quickly make use of the while loop, and when we let's consider while left is less than right here. So while the 2 pointers haven't crossed, we can connect the current start node to the current end node. How can we connect? Just give here nodes of left plus plus dot next equals nodes of right, right? R we have considered. So let's give here R. So next step, let's check if the left and right have not met yet. Nothing but we are checking if the left and right pointers haven't met yet, right? So how can we do that? I'll just write a simple if condition. If left less than, right? Then only we can connect the current end node to the next start node. This is simple. Nodes of, let's decrement the right, dot next to the, let's initialize this one to the nodes of left. This is fine, right? I hope these two steps are clear. Finally, let's come to the third step or the final step. We have to ensure that the last node's next pointer is always null. Why we have to ensure the last node's next pointer is always null? Because it avoids any cycles in the list. We don't need any cycles in the list, right? So that is the reason. We have to ensure that the last node's next pointer is always null. So I'll just give here nodes of L dot next here. Let's initialize this one to the null. Let me format this code once. Let me run the code now. So you can clearly see here the sample test cases are getting passed. Let me hit the submit button now. So you can clearly see all the test cases are getting passed here. So the code works absolutely correct. So let's quickly discuss the time complexity and the space complexity of the code that we have written here. So overall time complexity of the code here that we have written is big O of n. Why the time complexity is big O of n here? Because we are traversing to store the nodes in the array, which takes big O of n, right? Traversal to the traversal to store the nodes in the array. We are storing the nodes in the array. We know this one. We are traversing through the each nodes, right, to store that to store them in the array, which obviously takes big O of n. And also reordering the 2 pointers also takes big O of n. So overall time complexity would be big O of n here. So what will be the space complexity here? The space complexity here would be big O of n as well. Why the space complexity here is big O of n, not the big O of 1? Because we are making use of the array to store the nodes, which quite obviously requires big O of n extra space. So the overall space complexity would be big O of n. Here, overall time complexity and the space complexity of the code that we have written as big O of n respectively, right? So I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.